Hey y'all, welcome back to my channel Land Before Time, with your host, Littlefoot. If you didn't get that reference, you probably grew up on Dinosaur Train. Either way, welcome aboard. Today we're going to be solving valid parentheses. This is a great building block problem, as it will allow you to solve more complex stack problems in the future. You'll never know when you'll have to make a calculator. I mean, evaluating reverse Polish notation is a pretty popular question. So let's get started. Given a string S, containing just the characters, all of these three parentheses, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, every closed bracket has a corresponding bracket of the same type. Goal: determine if string S is a valid parenthesis. Moving on to some clarifying questions. The problem is pretty straightforward. I only have one question, which is, can we assume that string S will only have the following parentheses listed in the problem? Yep, you can go ahead and assume that. Alright, then let's go ahead and start working out some examples. Let's go ahead and use example 1 where we have a pair of parentheses. We know that this is a valid example since it matches all of the three requirements that we need in order to make a valid parenthesis. The first thing that comes to my mind is let's push every open parenthesis onto the stack, and if we see a closing parenthesis, then let's start popping it from the stack and see if it matches the correct open parenthesis. Just to make this a little bit more visually clear of what my idea is, we would go ahead and take the pair of parentheses that we currently have for this example. And we have this little guy here that's just basically our pointer. And this is just going to keep track of the point that we are during your iteration process when we iterate through the string. What we're going to do is we see here the current marker is here where we have an open parenthesis. So let's go ahead and add the open parenthesis onto the stack. Now there's nothing else left to do, so we go ahead and move it to the next one. And when we move it to the next one, we see that this is a closed parenthesis, so let's go ahead and remove this from the stack. And we're going to do a match to see what is the popped value with the current closed value. If those two are the correct match, then we know we have to keep searching. Otherwise, we know that it can't be a valid parenthesis. Let's take a look at example 3, where we have a open parenthesis and then we have a closed bracket. And try the same thing over here. So we'll go ahead, we have our little pointer, we know that we're going to put this onto the stack, and when we put that onto the stack, we go to the next one and we see that is a square bracket. So we go ahead and pop that and we do a comparison of the open parenthesis and the square bracket, and that is false, so we know that this is not a valid parenthesis. The runtime of the solution would be O of n, as we need to go through each character in the string. The space will be O of n as well, in the worst case where we have all open parentheses. Before we start coding, I'm going to take 30 seconds just to recap my solution and create a blueprint. Iterate over string S. If open, push to the stack. If close, pop the top character, compare to the top of the stack. If match, keep searching. Else, return false. And now it's time to display our rockstar coding skills. And there we have it, valid parentheses. One thing to note here is that I'm using a map with a lambda function. By doing so, it reduces the amount of conditions you need to check for in an if statement. I want to call this out because during my interview process, I've been asked to better optimize my code. And I'm sitting there like, this is definitely the optimal solution from a runtime spacetime standpoint. What do they mean? The interviewer gave me a hint by saying, in Java, is there something like a lambda function that you can use? And I'm like, oh, okay, so sometimes when it comes to optimizing code, they don't want it from a runtime spacetime standpoint, they actually want it from a clean code standpoint. If you like this video, give it a like, comment, share, and subscribe. Enjoy Hot Pocket too while you're at it. Happy Leetcoding, see you in the next one.